Hi friends, welcome back. In the previous session, we have seen LTI systems, how to identify the LTI systems from the impulse response. That means from h of t or h of n. So we have seen these kind of things already. So I'm just giving you recapitulation. So let's see, suppose if a system is static LTI system, then it must have h of t in the form of k delta t. It must be in the form of k delta t, and h of n must be in the form of k delta n. So this is what the static LTI system. And if it is a causal LTI system, then we can say h of t is equal to 0 for t less than 0, h of n is equal to 0 for n less than 0. These are the things what we have seen. Next, suppose if it is a stable LTI system, then the condition is integral minus infinity to infinity mod h of t dt is less than infinity. That means h of t must be absolutely integrable, and for discrete time case, summation n is equal to minus infinity to infinity mod h of n less than infinity. That means h of n must be absolutely summable. So these are the two conditions. Next, suppose if it is invertible system, then the condition has to be h of t, that is a system, convolution with a inverse system impulse response hi of t has to be delta t. This condition has to be satisfied. Then in the discrete time case, h of n convolution with a hi of n has to be delta n. So these conditions has to be satisfied. Suppose if it is static LTI system, causal LTI system, stable and invertible system. So these are the things what we have seen. Just I am giving you a recap here. Okay. Now let's take one question again based on these conditions. Let's see example. I'm just writing the question. It's a true false question. If the impulse response of a LTI system is periodic, then it is always non-causal and unstable. Is it true or false? True or false? This is the question. Okay. So try to understand. They said impulse response is a periodic. That means h of t or h of n is periodic. Then it is always non-causal and unstable. Of course, it is true only. Correct. Why true, sir? Why can't it be false? Let's see. First, it is a periodic signal. If it is a periodic signal, the first and foremost condition has to be satisfied. If it is a periodic signal, it is existing from t is equal to minus infinity to t is equal to plus infinity. What is that supposed to mean? It is existing for negative values of time also. So Whenever the system is, if the system impulse response is existing for negative values of time, then it is non-causal, because for causal LTI system, h of t has to be 0 for t less than 0. It is not satisfied. So definitely it is a non-causal. Next, if it is a periodic signal, if you take modulus of that signal, then that modulus under that area under the modulus of the h of t, then it is definitely going to be infinity. So I can say yes, it is going to be true. So it is non-causal and unstable. It is always. Remember that. Okay. So for periodic signal, periodic exist between t is equal to minus infinity to t is equal to plus infinity. So that means h of t is not equal to 0 for t less than 0. That implies non-causal. Non-causal. And if it is a periodic signal, if you take modulus and if you try to find out area under the curve, it is always it is always equal to infinity. Then that means it is unstable. So because of these two reasons, I can say it is always non-causal, it is always unstable. Okay, take it. You already got this. Okay. Question number 38. For Bibo stability, of an LTI system, which is true, which is true. Option A. H of t, that is impulse response, is integrable but may not be absolutely integrable. Option B. H of t will have finite support. Finite support. Option C. Step response will be absolutely integrable. Option D. Step response is bounded. Step response is bounded. So, which of the following option is correct? Listen here. First option, h of t is integrable but may not be absolutely integrable. That means he said integral minus infinity to infinity h of t dt is less than infinity. And here they said, but integral minus infinity to infinity mod h of t dt may not be less than 0. Less than 0. But we require this one. Mod h of t integration has to be less than infinity. This less than infinity or less than infinity or not, it won't make any difference for us. I hope you understood. So this is the condition what we require. That's why. So it may not be though. So in that sense, it is not the correct answer. It has to be absolutely integrable. If it is integrable or not, we don't care. We have to see only whether it is absolutely integrable or not. Next, second option. H of t will have finite support. What do you mean by that finite support? Finite support means it is bounded. That implies h of t is bounded. That's what the meaning of it. So whether it is bounded or not, it is not the matter for us. What we actually require, h of t must be absolutely integrable. That is also not correct. So option B is also not correct. Step response will be absolutely integrable. That means what they said, integral minus infinity to infinity mod s of t dt less than infinity. So that's what we require. Less than infinity, sorry. Less than infinity. That's what they are saying that. But here we require h of t. That means impulse response has to be absolutely integrable, not the step response. So this is also not correct. But if you observe carefully, the option 4 is correct. Why, sir? Step response is bounded. What is a step response actually? Step response is integral minus infinity to t h of tau d tau. So if it is bounded means this integral is also less than infinity. So definitely yes, option D is correct. Okay, take it. Find the overall impulse response of the system. Find overall impulse response. Find overall impulse response. For this system, we require to find overall impulse response. Okay. Try to understand. This is a one system and this is another system. Two systems are cascaded. So if two systems are cascaded, then what is the overall impulse response? If I know the impulse response of this system is, let's say, h1 of n, and here we know h2 of n, then what is the overall impulse response? If they are cascaded, that is nothing but h1 of n convolution with h2 of n. That is what the overall impulse response. Now, I don't know what is the impulse response of this system. I know the impulse response here. So I am trying to find out impulse response of this system. How we can do that? So listen carefully. We know one thing. For this system, if input is x of n, for this system, if input is x of n, we are going to get output is y of n. Okay, that's very good. Now my question, if x of n, the input is delta n, that means if I replace x with delta, then we have to replace y with h, that means h of n. I hope you understood. So whenever the input is impulse function, the output is called as impulse response h of n. So let's call it is h1 of n better, h1 of n, h1 of n. So you tell me, what is h1 of n here? For this system, what is h1 of n? Which is wherever x is there, that has to be replaced with impulse, that is delta. So simply it is delta n minus 1 by 2 delta n minus 1. So we got h1 of n and we got h2 of n. Then what is the overall impulse response h of n? Which is h1 of n convolution with h2 of n. h1 of n convolution with h2 of n. So I am taking here h of n is equal to, what is h1 of n, which is delta n minus 1 by 2 delta n minus 1, is convoluting with 1 by 2 whole power n u of n, 1 by 2 whole power n u of n. Now let's see, because convolution is a distributive property, first I will do the convolution with impulse, next I will do convolution with delta n minus 1. So if any signal is convolution with impulse function, it is going to be the same function. So which is 1 by 2 whole power n u of n minus 1 by 2. Any function convolution with the delta n minus 1, we are going to get the same function with the same shift. That means 1 by 2 whole power n minus 1 u of n minus 1. Now if you observe carefully, 1 by 2 whole power n minus 1, if I multiply them, minus 1 plus 1 get cancelled. So if I take 1 by 2 whole power n common out, we are left with u of n minus u of n minus 1. And we know this is a difference equation of step function u of n minus u of n minus 1, which results in delta n. So it is nothing but 1 by 2 whole power n delta n. And from the product property, any function is multiplied with delta n has to be replaced with 0. So if I replace n with 0, then this is going to be 1, then this is going to be 1. Finally this is delta n. So this is what we got. Finally the impulse response is equal to delta n. Okay, I hope you understood. Now from this I want to give more information on this. This function, this system having impulse response h1 of n, this system having impulse response h2 of n. If I convolute them h1 of n, h2 of n, what we are getting is delta n. What do you mean by that? Can I simply say, for this system, this is nothing but the inverse system, and for this system, this is nothing but the inverse system. So from this I can conclude that h of n is equal to h1 of n convolution with h2 of n is equal to delta n. I told you, invertible system having impulse response and inverse system having impulse response. If you convolute them, you are going to get delta n. So I can simply say h1 of n and h2 of n are inverse systems with each other. Okay, take it. Next example. Find overall impulse response. Find overall impulse response. and obtain the condition for stability. Condition for stability in terms of alpha and beta. In terms of alpha and beta. Okay. The system is shown like this. For this system, we have to calculate overall impulse response and a condition for stability. Here, if you try to solve it, you will do one silly mistake here. What is the silly mistake is? First of all, let me explain this question. We are having two branches which are parallel, and this one is cascaded with overall transfer function here. Okay, overall impulse response. Now, if I ask, what is the overall impulse response of these two blocks or these two parallel blocks? So definitely everybody will say, so this is having beta delta n minus 1. So this is having 1. So that 1 plus beta delta n minus 1. So many people think that. So this is overall system having impulse response 1 plus beta delta n minus 1, which is absolutely wrong. Which is absolutely wrong. Why it is wrong? So try to understand. First, I told you to find the impulse response, the input must be impulse function. So if the input is impulse function delta n, the same delta n comes here. Next, if input is delta n, we are going to get impulse response here, which is beta delta n minus 1. So here, what is the overall impulse response? Let's call it is h1 of n, which is delta n plus beta delta n minus 1. So this is what the overall impulse response. So many people do mistake here. So instead of delta n, they can assume it is 1, because in the control systems, so mostly we will go with a 1. So because there we are not using time domain, we are using the frequency domain or S domain or Z domain. So in those domains, for impulse function, the Laplace transform is 1, the Fourier transform is 1, and Z transform is also 1 for impulse function. So all the transforms are 1. That's why they will take it as 1. So but here we are using the time domain. So in the time domain, we have to consider delta n only, not the 1. So please keep that in mind. Okay. Now we got h1 of n, then we can directly find out what is overall impulse response. H of n is equal to h1 of n convolution with a H2 of n. So this is delta n plus beta delta n minus 1 convolution with the alpha power n u of n. Alpha power n u of n. So for this I am going to get convolution distributive property alpha power n u of n plus beta alpha power n minus 1 u of n minus 1. So this is what the overall impulse response I am going to get. Okay. Once we got this is the overall impulse response, you tell me. To make the system stability, what is the condition on alpha and beta? So first understand alpha power n u of n, which is a right-sided exponential. Alpha power n minus 1 u of n minus 1, that is also right-sided exponential. Why? Because it is starting from 1 to infinity. It is starting at 1 and ending at infinity. So definitely it is a right-sided exponential only. And beta is simply a constant. Beta is simply a constant. Now, right side exponential, if it has to be absolutely integrable, then it must be decaying exponential. We already seen this. So, right side exponential has to be absolutely integrable if and only if it is a decaying exponential. So, to say it is a decaying exponential, we have to say mod alpha less than 1. Mod alpha has to be less than 1. Then we can say decaying exponential. And beta is simply a constant. It can be any value. Beta can be any value. Can be any value. There is no restriction on beta. At the same time, you cannot consider beta is equal to infinity. This is not in your hand because beta you have to design in the system. So in the system we don't have the infinite values are like that. So we cannot consider infinity. So that's why in this regard I cannot say beta can be any value except infinity like that. So I can simply say beta can be any value because we don't have the facility to take the beta value is equal to infinity. I hope you understood. So take it. LTI systems with periodic inputs. LTI systems with periodic input. Is a periodic input. So this is a very important concept. So many questions were asked based on this concept. So let's see, try to understand. I'm not giving you any proof here. I'm just giving you the statement. What is that statement is? Suppose if you consider LTI system. For this system, input is x of t, output is y of t. If the system is LTI system and input is a periodic signal, definitely the output is also the periodic signal with the same period as x of t. That means, so for LTI system, if you give input which is periodic signal with period, let's say t, then output is also a periodic signal with a period t. So it may not be the same shape or curve like that, but definitely that is going to be a periodic signal. So that's what the meaning of it. Understood? So I can write that statement. LTI system produces periodic output for periodic input with the same period Okay, what do you mean by that? Suppose For LTI system, if x of t is a periodic with period t, then y of t is also periodic with period t. That's what the meaning of it. Sometimes with the same period or with the same frequency also we can say. With the same frequency. We can call it a same frequency also, because if period is same, definitely the 1 by t value both are same. So I can say frequency is also the same. So I can say, if I say frequency here, what is the frequency here? Fundamental frequency, which is 1 by t. Here also the frequency is equal to 1 by t. Suppose, let's see one example you can understand. LTI system usually shown like h of t. LTI systems are represented with h of t. For this system, if input is, let's say, a sine omega naught t plus theta. Now, first we have to understand h of t having Fourier transform is h of omega. This h of omega is called as transfer function, or sometimes called as frequency response. This is transfer function or frequency response. Now listen carefully. For LTI system, h of t is the impulse response, and for that h of omega is the frequency response. If the input is this one, then what kind of output we are expecting? We are expecting the output in this manner. First, we have to calculate at omega is equal to omega naught, what is h of omega? That is h of omega naught. Usually h of omega naught is a complex number, so it is having both magnitude, that is h of omega naught mod, that is magnitude, and angle h of omega naught. Once we got the magnitude and angle, if the input is this one having magnitude A, phase is theta, then what will happen to the output is, simply we are going to get output which is A, that is magnitude, multiplied with the magnitude of the transfer function, which is h of omega naught, sine omega naught t plus theta, and additional phase has to be introduced into the phase, that is plus angle of h of omega naught. So this is what we are going to get. Clear? In a similar way, it is cos function also, we are going to get same kind of output. So if you observe carefully, the input is having frequency omega naught, the output is also having frequency omega naught. But if you observe carefully, here the magnitude is A. What is the magnitude here? A into mod h of omega naught. What is the phase here? Theta. Here the phase is theta plus mod h of omega naught. So magnitude of the signal can be changed and the phase of the signal also can be changed, but its frequency will never change, because we are going to get same period and same frequency. I hope you understood. So frequency will never change. Magnitude may change and phase may change, but frequency of the signal does not change. I hope you understood. Take it. Let a signal A1 sine omega 1t plus phi 1 be applied to a stable LTI system. Stable LTI system. Let the corresponding steady state output be represented as be represented as a to f of omega 2t plus phi 2. Then which of the following statement is true? Then which of the statement is true? Option A. F is not necessary a sine or cosine function. Not necessarily sine or cosine function, but must be periodic with omega 1 is equal to omega 2. F must be a sine or cosine functions with a1 is equal to a2. Option C. F must be a sine function with omega 1 is equal to omega 2 and phi 1 is equal to phi 2. Option D. F must be sine or cosine with omega 1 is equal to omega 2. Which option is correct? Next example. An LTI system has h of omega is equal to 1 by root 1 plus omega square angle minus tan inverse omega. If input x of t is equal to sin t, then output is options 1 by root 2 cos t, 1 by root 2 cos t minus pi by 4, 1 by root 2 sin t, 1 by root 2 sin t minus pi by 4, t minus pi by 4. Which option is correct? Okay. So in this question, option D is correct. Why? If input is a sin omega 1 t plus phi 1 and output is a to f of omega 2 t plus phi 2. So here I told you, whenever the input is a sinusoid, then definitely its amplitude may change or its phase may change, but its frequency has to be changed. Its frequency has to be same. So if its phase is changing, sine may be converted into cos, but it can never be sine or cos. Sorry, it can never be other than sine or cos. I hope you understood what I am trying to say. So the system is introducing some phase and some magnitude. Suppose if the system is introducing 5 by 2 phase, 90 degrees phase, then sine curve will become cos curve. That doesn't mean that sine curve is going to be some other function other than cos. No, it can be either sine or it can be either cos. So either cos or sine curve only we are going to get in the output, not more than that or anything else. So definitely it has to be sine or cos, one thing is clear. And I told you A1 may change, that means magnitude may change. Phi 1 may change, that means phase may change. But frequency has to be same. So which is nothing but this one. Option D is correct. Now coming to this question. X of t is equal to sin t. X of t is equal to sin t. That means it is a periodic input and we are having h of omega like this. I told you, whenever this kind of things we see, so we just see how much is the omega naught value. Omega naught, which is sin t means omega naught is equal to 1. Then at omega naught, what is h of 1? H of 1. So which is 1 by root 2 angle minus 45 degrees. That means minus pi by 4. Minus pi by 4. Now if you observe carefully, at this frequency, this is the transfer function we are getting, means we are having the magnitude, we are having the angle. So if the input is this one, we have to multiply with the magnitude and we have to take the angle, which is minus pi by 4. So I can get y of t is equal to 1 by root 2 sin t minus pi by 4. Magnitudes get multiplied and phase getting added. Okay, take it.